Hello. Welcome to the Clark Planetarium Art in Satellite, what is it called again?
Art, Satellite, and Imagery. Oh, wait, oh my gosh. Satellite Imagery and Art.
Satellite Imagery and Art.
There we go.
We are the Illuminate Virtual STEAM Lab, and we are here today with the Clark Planetarium's very own Cynthia. She's going to show us some very cool art and satellite art in satellite images, because that is science and art talking to each other and playing well. So I'm Sky. I'm with the Arts Alliance, and I'm the STEAM Lab manager, and I will be popping in to deliver the questions that you all write to Cynthia in the comments on Facebook or on YouTube, wherever you're watching. Just if you have a question, write it in the comments, and I will pop those over to Cynthia. So Cynthia, take it away.
Thank you. Yeah, Sky said my name's Cynthia. I'm from the Clark Planetarium, and I love getting to do these opportunities where I get to talk about how science works with other aspects of our society. So whether it's, mathematics, engineering, or art. A lot of people don't think that art and science connect, but they really do. So I'm really excited for our presentation, and then I've got a little activity to show you. I'm going to do a paint along kind of style activity. So if you want to paint along with me while I'm doing my presentation, feel free to grab some supplies. You can get paint. I'm going to be using acrylic paint today, but you can also use colored pencils, markers, any other kind of paint. It's really up to you and what kind of medium you love. So gather your supplies while I'm talking, and then sit and listen, and then we'll get to the activity at the end of the presentation. So give me just one moment to pull up my presentation and we will get started. Okay. Here we go. Okay. Oops. Scrolling too far forward there. Okay. So, welcome to Art and the Cosmic Connection. That's what I like to call it. It is also satellite imagery and art, but it's a really, really cool activity and presentation that goes well together. That was actually created by two artists named Monica and Tyler Aiello. They worked really closely with NASA to get some of this really cool science and space information and data, and incorporate it with a lot of the different art techniques that they use. And you can see in these pictures here that they use a lot of that space data to create their own artwork. So they've done a lot of work with NASA and seen how space science can work really well with art. So go check them out if you want. This is the presentation that they made. I've tweaked it a little bit for today's purposes, but they definitely get the credit for creating this awesome idea. So what we're going to talk about today, like I mentioned, is satellite imagery. And so what do we do when we want to study moons and planets that are really, really far away? We use robotic photographers. And these robotic photographers are, like I mentioned, satellites. And so satellites are things that are orbiting the Earth, and they usually have some really awesome instruments on them. Most of them have cameras. Not all of them are regular cameras like you take out to go do a photo shoot on your own, but they're really, really important cameras that are going to capture some important data points that we'll talk about a little later. So we use these satellites and also telescopes here on Earth, actually on the surface of Earth, to get a lot of different kinds of data. And this data helps us understand our universe and our solar system a lot better. And it's awesome because scientists can't easily travel to all the places we want to study. We can send astronauts out into space, and we've been to the moon, and hopefully we're going to get to Mars pretty soon. But it's really hard to send people to space. It takes a lot of resources. It's pretty dangerous, and they can't stay out there for very long because of limits of supplies or just of human body. It's hard for the human body to stay out in space for a while. So it's really awesome that we have these robotic photographers that are going to help us understand more about our solar system. So I'm going to talk about the couple different features that you can see with our telescopes that help us give information about planetary bodies, or celestial bodies is kind of a more encompassing term to use. So these celestial bodies have a lot of different surface features. And surface features are like on Earth, surface features would be things like mountains, trees, lakes, things that you can see if you looked down on it. And so some of these things are going to translate to our solar system and our space exploration. So the first thing that we're going to talk about is this beautiful circle. And so looking at the circle shape that we have here next to this image of, take a second to guess what you think it is. I think you all probably would guess that it is in fact a crater. And so circles, when we see circles through our satellites, through our space imagery data, then we know that those are going to indicate some kind of impact. So circles usually mean craters. So if we're looking through our telescopes that give us lots of awesome data about these celestial bodies, and we see circles, these circles are going to let us know that there has been an impact, a crater. Something large has rammed into another celestial object and left a mark. And because lots of reasons for gravity, they usually make these nice, clean circles. And so you can also use other information about the crater to give you a little bit more information about that impact. I don't know if you can see the kind of faint larger ring around this crater. That gives you a little bit information about the impact when it first happened, how it affected the land around it, aside from just the really big crater, the hole that it smashed in this celestial body. And so this is actually from Mars. This is a crater from Mars in the northern Elysium Planitia. So helps us kind of get a little bit more information on that area, and that it's been through some hard times in its cosmic history. So here's a couple more examples of craters or circles that we're going to use later. So this is from Mercury. And Mercury, I don't know if you all know, but Mercury doesn't have an atmosphere. So knowing that from other observations that we made, and then taking pictures of the surface and seeing all these craters, those two bits of information kind of work together to make sure that we really understand Mercury. So not having an atmosphere means that there's no air resistance to slow things down when things come to hit Mercury. So not having any air resistance means that you're going to get a lot of impacts because those meteors don't burn up in the atmosphere before they reach the ground. So Mercury has a lot of scars from these asteroids that have been hitting it, and you can see that in the planetary surface. You can see all these different circles that we talked about that indicate craters. So circles are our first kind of key thing to look for in our satellite imagery. And it's also a really important shape in art. So circles are an awesome foundational shape, whether you're doing pencil work, line work, and you need to start with a basic circle to kind of get you started on whatever form or shape you're going to make. So circles are really important. So keep in mind all these different shapes and aspects that we go over because we're going to bring it back to our activity in the end. But after we've talked about circles, we're going to talk about a different kind of circle, which is a blobby circle. Blobby isn't a very scientific way to say it. A lot of people often call them organic shapes because it's a little more scientific than blobby, but also organic shapes are made by things organic, or they are related to life, kind of, is the way to think of organic. And so if you see a blobby shape like the one we have here on the screen, and then this image that we have, you can kind of make a guess of what the image is, even though it's kind of a funky picture. But organic shapes on a planetary surface usually mean a volcano or a lake. So there's two kind of differing explanations for a blobby shape on a planetary surface. You can have a volcano, which is the picture that we have here. This is Olympus Mons, the largest volcano in the entire solar system, actually. much bigger than any of our volcanoes, but it's massive. And you can see it around the rim there, where it's a little bit lighter. That's the blobby shape that we're talking about here. And then at the very center, you can see that's the top of the volcano where stuff would spew out. So volcanoes are really important because they indicate geological activity. So that's the surface of the planet or celestial body moving and shifting, just like how our planet, the tectonic shapes move and shift and create earthquakes and other events. So volcanoes are really important to get information on, to understand what's going on the surface of the planet. But so are lakes. Lakes indicate that there is a liquid on the surface of the planet. Now, not a lot of the celestial bodies in our solar system have liquid. The Earth is the only one that we know of so far for sure with liquid water. However, I think it's at the end, a cool picture of different kinds of liquids that might create a lake on a celestial body. So these blobby shapes can also indicate that there is a liquid on the planetary surface. Okay, here's another example, just to give you an idea of all the different varieties of blobby shapes that you have. This is from Venus. And so you can see that there's really these long kind of streamers coming out from the center of it's another volcano here. But you can also see that there's different kind of shades of the blobby shape, which are going to tell us a little bit about the different lava flows. And so they kind of look like they're layered on top of each other, and that's because it's erupted over and over again, creating new blobby shapes, telling us that Venus has a very geologically active surface, which we've then put alongside other data that we've gathered from the atmosphere and from other information from our satellites to confirm that it really is very geologically active. So it's really cool. Also, side note, I'm very excited about it. There's an awesome paper about different biosignatures, if you're into biology in space, different biosignatures found in the atmosphere of Venus. So check that out if you have time. Okay, moving on. So we've talked about circles, talked about blobs. We're going to move on to not quite shapes, but lines. So these lines are specifically straight lines. So when you see a straight line on a planetary surface, that means, going back to the volcanoes, that there's been tectonic activity. Now, volcanoes aren't the only thing that indicate tectonic activity, but you can see here that there are tons of lines. This looks like a microscopic image to me. However, it's not. It's actually ice. It's ice on Jupiter's moon Europa, which is one of my favorite celestial bodies in the solar system. But you can think about it, if you had a big, huge sheet of ice and on a lake, and somehow the water underneath started moving, those big sheets of ice would shift and create these nice long cracks, big long lines along the surface. So that's a really interesting thing to note for scientists, because if there's lots of cracks, then makes us start to wonder what's underneath the surface. Europa is thought to maybe have a giant subsurface ocean. And that giant subsurface ocean would be really cool because it would probably be made out of water, which water is good for life. So understanding those lines on the planetary surface are really important to get a little bit of an understanding of what's going on underneath. Here's a couple of other pictures. This is also Europa. But this is just going to show you a little bit of a different view. You can see the whole body here, and it's got cracks, really, really long cracks all over its surface, which is really, really cool. That means the entire planet is geologically active. So straight lines are cool, and they mean tectonic activity. So what does it mean if it's a squiggly line? This picture on the right here looks like something you might see on Earth. And so based off what I said just a minute ago, Earth is the only planetary body in the solar system with what? With liquid water. So this is actually a picture of Mars. And before you jump to any conclusions about there being water on Mars, there isn't, unfortunately, that we found currently. However, there are signs of water being on Mars in the past, and that's what this picture is of here. So squiggly lines are going to show us erosion. It could be liquid or it could be wind, but these ones here look a lot like a riverbed that you would find here on Earth. And so squiggly lines, if you think about it, if you pour water onto like in the desert or something on a rock, you can see it, it'll move around things in its way, which is why we can infer that from squiggly lines. And so that's what's going on in this picture. At some point in Mars's past, there was liquid and it was moving around its dusty, dry surface, although maybe it wasn't so dusty and dry in the past. There's another example here also from Mars that shows a kind of a different view of water runoff or liquid runoff, where it's kind of carving out these fun little canyons and creating squiggly lines in a different way. And erosion by wind is also going to look really, really similar to that. It's going to create those kind of winding, curving patterns. Okay, so the next thing we're going to talk about is color. And so you'll notice in the past few pictures that I've shown you, we've had varying kinds of color. You can see in this one and then this one of Mars, they're essentially what you would imagine the surface to actually look like. Same with the moon here, the gray one on the left. So those are what we call true color images. So the true color means if you went out in space and you looked at it with your own two eyes, that's what you would see. However, this beautifully colored moon on the other side here, that's probably not true color. I think you could infer that for yourself. So a lot of these images have color added to them. And a lot of people, I think, get a little bit hurt. They're like, oh, why would you lie? Why would you tell us that it's something colored a different way than it actually is? But the color is actually really, really important for scientists to gather even more information about the surface. So these satellites that we have in orbit and telescopes on the planet use a lot of different tools to take these images. And they take images not just in visible light, but also in infrared light, radio waves, X-rays, ultraviolet rays. And so looking at a planetary body in all those different waves or energies, it's going to give us different information. It's going to tell us a lot about, I think this one, let me double check here. Yeah, this one is showing us different surface compositions. So that means we took a picture, not just with a regular camera, with a special camera that was looking at a different type of wave. And that gave us the information to then color it. So it looks like this beautiful color, but it's actually giving us information about what is in the soil or the regolith of the moon. And that way we can understand a little bit more about what it's made out of and what maybe created it in its history, what different elements came together to form this celestial body, or what different asteroids, what kind of asteroids hit into it and left little pieces everywhere that we can now see. So color is really cool and really important. A question, yes.
The question is, does a planet have to have an atmosphere to have wind?
Ooh, a great question. So I am not a meteorologist by any means. However, as far as I understand it, yes, you're going to need atmosphere because wind happens when there's different temperatures of air and it's going to move because if you remember right, cold air sinks and hot air rises. Next time your AC turns on, go stand by it and you can feel if it's cold AC, it'll feel by your toes. And that's how you know, because it's a little bit denser. So when that's happening, that's what's going to create your winds along with lots of other features. So like Mercury, like we were talking about, that doesn't have any atmosphere, probably doesn't have a lot of wind. There are outside factors. There's stuff called solar wind, which comes from the sun, though it doesn't act quite like regular wind like we know it here on Earth. So an excellent question. For the same reason, there is no wind on the moon. So you can't actually go and enjoy a nice breeze on the moon. That's why also when the astronauts put the flag on the moon, it doesn't flap in the wind like a regular flag. It kind of just sits there. It's just not very exciting, but it's kind of cool. You can see the flag the whole time. So great question. Okay, another quick example of color is this other, oops, sorry, I've lost my notes here. Okay, so this is another example of color. This is an area called Cullen Patera, and it's on Io, which is a moon, and it is the most volcanically active body in the solar system. So it has tons of volcanoes. And if you remember when we talked about blobs, there's a lot of different blobby shapes going on in this picture. And you can see that there's different colors as well. So we've got the blobby shape and then the different colors. And the colors were taken by using different filters on the camera. So a red, green, and violet filter of the same camera, and then processed and enhanced to show those color variations so we could see the different lava flows and about how the surface is changing that way. So super cool uses of color, which is really important in art as well, because you use color to show lighting, you use color to show what the material is made out of. In planetary science, you can also use color to show things like topography, or we mentioned surface composition, or even gravity. You can use the color to show where there's more gravity on a body. So color is super useful. And I mentioned it briefly just now, but showing contrast or difference in shading. So these are two really cool images, both from the same celestial body named Iapetus. I always get it wrong, but Iapetus, I believe, is the right one. But this is showing us value. So value is light and dark, or shade and highlight. And Iapetus is really cool because half of it is super dark. Like you can see here, this material is very, very dark. It absorbs a lot of light, whereas the other half of it is super bright white, and it reflects a lot. So scientists aren't really sure what's going on Iapetus, but it does tell us about how different things reflect light. So if something's very, very reflective, there's a good chance that it's made out of ice. So ice sends a lot of the light that hits it back out into the universe. And so studying places like Iapetus will teach us a little bit how different materials are going to react to light and what their reflectivity is going to be like. Oh, there we go, Iapetus. Okay, the last bit we're going to talk about is texture. And this really, really fun image is from Titan, which is a moon, sorry, not Titan, Triton, a moon of Neptune. And Triton, it doesn't have any of those craters that we've seen in a lot of the images. And it doesn't really have many of the other shapes, but it does have this really weird texture. Its texture is kind of funny enough that people call it a cantaloupe. It's like a cantaloupe terrain. So it's kind of like wavy and crackly. And so the fact that there's no craters and it does have this wavy, crackly texture tells scientists that it probably is pretty geologically active again, because active geology, tectonic plates moving, volcanoes flowing, are going to cover up anything that happens to the surface. So if an impact comes and creates a crater, but then there's a volcano nearby that flows, it may fill up that crater and kind of erase it from that geological history that we like to call it. So texture is a really cool way to also show a little bit more about what's happened to the surface, or what's going on underneath the surface that's creating these different textures on the top of the planet. So love the cantaloupe moon, super cool. And I think that's the end of those different techniques that we use to study a surface. And so with those techniques that we've talked about, we've got circles, we've got blobs, we've got straight lines, squiggly lines, color, value, and texture. You can combine all those different aspects and use them to kind of story tell. So with this image here, there's a lot going on. And so if we take it bit by bit, look at different features on it, then we can kind of piece together its history as a planetary or celestial body. So looking at it here, we've got the main feature, which is this giant circle, a big hole. And we learned that circles mean craters. So this is showing us a big impact that happened on the surface of this this celestial body. But what's really interesting is that there's several kinds of lines also interacting with this impact. We've got the big lines that are interrupted by the impact, and then we've also got lines that are going across in front of the impact. So that is telling us that there was some geological activity, and then the impact, and then more geological activity that created those lines on top. So it's a really cool way to combine these different techniques. And then you can also look a little bit at the texture, the surface texture, which shows it's a little cracky, so it's probably ice. And then the coloring. The coloring is not true color here, but it's going to tell us a little bit more about the composition for this image. So that's a really cool way that you can add all these concepts together and really talk about the history of a planet or a celestial body. So I'm going to stop sharing here. And now I'm going to show you how you kind of use some of these aspects to create your own work of art. Just like Monica and Tyler, they use all that information and all those techniques to create their own space-themed art. So I'm just going to scoot back a little bit here so you can see my workspace. And feel free to paint along with me, or just sit and watch to see how it works together, or put as many questions as you like in the comments, and I'll try and answer them as I'm showing you how to use some of these techniques. But I'm going to start with a canvas. I pre-painted mine, so you didn't have to sit and wait and watch me paint for a long time. But I've got a setup with some newspaper, got my paints. You can see I've already started mixing some of my colors. My paints over here, some water. I'm using acrylics, so you can use whatever you want. And I've got my base painted already. So if you don't have that done, no worries. But this is a fun color, and I chose my orange and my yellow because I've decided that my color aspect is going to be based on elevation, on topography. So the red-orange area over here is going to be higher elevation, and the yellow here is going to be lower elevation. So I'm just going to jump right into it. I'm going to start with a volcano because I think volcanoes are really cool. And so a volcano is going to be like a mountain. So it's going to be taller and a higher elevation. So I'm going to get some red to show that it's higher than my orange here. I'm going to mute it with a little bit of yellow so it's not too tall of a mountain. But once I've got it, I'm just going to go ahead and put in a blobby shape right over here. I think I need more red. More red, and we're going to go for a Bob Ross aspect here where we're not going to worry about mistakes, only happy little accidents.
So we have a new question for you.
Yes.
From Jennifer Van Orden. She'd like to know, what is your favorite planet?
Oh, my favorite planet? That's mean. They're all so good. I mean, I feel like Earth is a cop-out because I live here. So I do love Earth because I'm a big nerd for biology. So Earth is one of my favorite, but I really love probably Saturn because the rings are beautiful. And if you want some of the most beautiful space imagery, just to make you happy, look up Cassini, the Cassini spacecraft. It took amazing pictures of Saturn, and I just love those so much. So it varies by day, but probably Saturn. This image that I'm making here is not based off of any planet, which is the awesome thing about art. You can take stuff from your everyday life. You can take stuff from science fiction, and create your own artwork around it. Okay, there's my beginning of a blob. It's kind of hard to tell with my orange, but I'm going to start on another feature. So we've got a blob to show our planet. To show our volcano. And now we're going to add another surface feature, and we'll slowly build up. So in my lower elevation here, water usually runs, because it runs downhill, it's going to run into lower elevation. So I want to have a river maybe not of water, maybe it's methane river, maybe it's some other liquid. And so to create my river, since it's a lower elevation, I'm going to use blue. Not because it's water again, but because it's going to show that it's a little bit of a lower elevation. Oops, got my white to make it a little brighter.
We have another question from Stephanie McGinnis. She'd like to know, do you think it's ever hard for scientists to tell a circle from a blob on a satellite image?
That is an excellent question. I think they probably do have a hard time sometimes because, like in that last picture we were analyzing with all the cracks and all the different features playing into each other, it's really hard to tell what was there first or what impacted the other things. So I think they probably have a hard time sometimes. But that's why redundancy in data is so important, because then you can say, oh, by just looking at this image, I think that it's probably a blob, or I think it's a circle, and then you compare that to other information that you've received from other sources, other satellites, and then use that to kind of confirm your idea. So you don't have to worry about getting it right first time, but you can work with other people, other scientists, to kind of get a full picture. Here I'm adding a little lake at the bottom of our mystery liquid. Gonna give it some nice round edges. Ooh, where's my white? Mixing colors might be the hardest part of painting for me. Honestly, I don't paint as much. I usually use different mediums, but it's so fun to be able to have the opportunity to try a lot of different mediums. But mixing colors, man, that is you could spend a long time mixing colors. But it's really awesome because you can get, like I mentioned before, inspiration from the world around you to see what kind of colors you'd want to include or what kind of shapes, because blobby shapes don't all look the same. Okay, I think we need some craters. Actually, before I do craters, I'm going to do a couple tectonic lines. So because tectonic lines are going to show cracks in the surface, they're probably going to be really deep. So I'm gonna make them purple to show that they're really deep. They go deep down into the crust of the planet. It's going to mix some blue and some red to get my purple. Purple's also just a great color in general. And I'm gonna add them over by my volcano. Not the straightest line, but it works. You can also see here with my gradient between the different colors of the elevation how it's kind of more abrupt up here and a little more faded down here. That's also going to show you a little bit like kind of like topography lines on a map. You've seen those maps where they have all the lines that show you how steep something is. That's going to work the same way, at least in my painting here, where it shows you that since these colors are contrast, it's probably steeper. It's probably a cliff or something, whereas opposed to here, it might just be a nice gradual slope coming down to our lake bed. We need some more cracks. Let's add the river going over one. And I realized I forgot the top of my volcano here. We need a hole in our volcano where the lava comes out. So let's add that. We'll just make it kind of orangey so you can tell. And because since a hole, it's going to have a lower elevation. Well, that's not orangey enough. Here we go.
So it looks like we're coming up on 35 minutes.
Okay. Well, we've got some good stuff on our artwork here. what's awesome is that you can always come back to your art, come back to it later. Here, I'll show you a closer up look of my beginnings of my space painting. Very, very nice. We've got different colors. You can kind of see the top of my volcano. Got some tectonic activity. Got our nice organic shapes to show a volcano and a river. So art is all about having fun. And incorporating science is an added bonus.
Mm-hmm. Yay!
Yeah.
Do some silent applause.
Yeah.
Well, thank you so much, Cynthia. Don't forget, we're going to do this again on the 18th at 5 o'clock, right? I think 5 o'clock.
6.
6 o'clock. Yes. And next time I'm bringing my paints because
yes,
yeah, can be awesome.
Paint along together, Sky, with everybody else.
Yes.
Awesome.
Thank you so much. See you.
Thanks for having me.
Bye.